Alright, hello and welcome back everyone. This is video number 29 associated with problem 29 from a AP Physics C Mechanics multiple choice test. So the problem we're solving today is the graph shows a conservative force F subscript F as a function subscript X as a function of position X acting on an object in a closed system. If this is the only force acting on the object, what happens to the potential energy of the system as the object moves from 0 meters to 0.1 meters, as shown on this graph, which this should be force in newtons. And our options are A, it increases only, B, it decreases only, C, it increases then decreases, D, it decreases then increases, and E, no change. So the concepts we're looking at here are force and potential energy. Some equations that we have for those. These, I do not believe these are on the useful equation sheet, so these are some that you should commit to memory. But this is an equation for force. Force is equal to the negative derivative of potential energy with respect to x. Another equation you should memorize is for potential energy. So your useful equation sheet gives you, I believe, two equations for potential energy. I think three. One is spring potential. One is gravitational field potential, the one that is negative GMM over R. And the other one is change in gravitational potential energy, which is mg delta H. So that's for when you have an object falling and the potential energy that it has as a result of the height, because gravity is pulling it down, there's potential there. But that's not what we're dealing with here. We're dealing with relating potential energy to force. So what this potential energy equation is U is equal to the negative integral of f dx. So what the integral means is the area under a curve. It's the antiderivative. It's the opposite of taking the derivative of something. So the equation that we are going to be using for this problem is this. So what we're going to do here is the area under this curve, the force here is negative, right? Because zero's here, so this entire area is negative area. And our equation here, essentially, I'm going to try to simplify this problem so we're not going to actually need to use math. We're just going to try to understand the concepts at play here. That way we're not going to need to solve for values. So integral of f dx just means the area under the curve for force, the area under the graph of force. And here, since that area is above between the x-axis and the curve, this is negative area. So we're saying negative, and then this times this amount of negative area is equal to the potential energy. So that means our potential energy is going to be positive because it's a negative times a negative. Alright, so if our potential energy is going to be positive the whole time, it's going to only be increasing during this period. So we know that it cannot be B, decreases only. It can't increase then decrease. It cannot decrease then increase. And it definitely changes because looking at this graph, there is change. So that means our answer is going to be A, that the potential energy of the system increases only as the object moves from 0 meters to 0.1 meters. We found this out using this equation for potential energy. U is equal to the negative integral of f dx. And since this is a negative and the area under the curve is negative, it cancels out and becomes positive, which shows us that the potential energy is going to be increasing only. Thank you for watching. Let me know if you have any questions about potential energy, force, any of these equations, how I solve this problem, and make sure to check back in for problem and video number 30. Thank you for watching.